The input signal varies with the time like this, 0, 5 volt. So this is the transistor what we have. VB, you can take it to be 0. Okay, again, we have to proceed in the similar way. This will be IC. Here, this will be IB. And this is IC. So now what are the set of equations plus 5? If you want, I'll write symbols so that it will be easy for you. VCC minus ICRC minus VC equal to 0. Okay, then what about IB? So this will be V in minus IBRB minus VB equal to 0. VB is anyway equal to 0, so V in equal to minus IBRB. So what is value of IB? V in by RB. V in, if it is 5 volt, then 200 into 10 to the power of 3, 5 by 2 or 2.5 or 25 microampere. Let the beta of this transistor be approximately 133.3 is telling the beta of transistor. Okay, now I think I forgot. I am giving that one. So with this, let me check the what is VC? VC is nothing but VO now. That VC is nothing but the VO. Okay, let's solve for this. Let me bring this one here. So this VCE equal to VCC minus ICRC. VCC is 5. IC we don't know. So beta into IB. RC is into RC. If I substitute this, 5, beta is 133. Approximate, you write 133. RC is how much? 1,500. Oh, I didn't bring the IB value, no? IB value is 25 into 10 to the power of minus 6. RC is 1,500. $133 into 25.
VC is also 0, sir.
4.9875 or almost it will become 0.
Yes, sir. 133.3 we can write as 400 by 3, sir, approximately.
This one 400 by 3, yeah. Okay, what is this? We are getting this one. Can we plot now? No, similarly, when V in is 0, this is what when V in is 5 volt, no? What we have discussed for V in 5 volt. Let me adjust this one. We'll write equation for when V in is 0 volt. When V in is 0 volt, IB will be 0. I think I'm looking at the equations. IB will be 0. IC will be 0. Then VO, how much it will be? Again, the same set of equation, VCC minus ICRC minus VC equal to 0. This is 5 volt. IC will be 0. RC, this is V naught. Look at this data. When V in is 0, V out will be 5 volt. When V in is 5 volt, VCE or V naught. So what is the possible output waveform? The output waveform will be inverted one. Huh? I'll continue this so that. So how the output waveform? Output waveform will be let's start from here. So output waveform will be 0. So this is the point A, B, C, D. Let me adjust things. So this will be V in A, B, C, D, E, F, G, H. So when input is high, output will be low. When input is low, output will be high. Exactly if you draw below, no? Or I'll draw the waveform here. This is actually okay, correct, no? Yes. Okay, there's a marking should be, yeah, fine.
Sir,
The marking, it should start from A, B. I'll do one thing. A, B, C, D. I think this will be sufficient. What happened? Somebody said,
why
sir,
did you
yeah.
take why did you take V naught equal to VC, sir?
Hey, that is what you connect voltmeter here. This voltmeter what will be connected across collector and emitter, no? And the emitter is connected to ground. If you want to measure this voltage, you'll connect to ground, no? This other thing. And look at this emitter
Yes,
is
sir.
connected to earth. Huh? Yeah.
Okay, sir.
Try to notice the small the symbols here. So shall we call this a NOT gate? NOT gate, same thing, no? When input is high, output will be low. Input is high, output will be low. When input is low, output will be high. So this is the best example of NOT gate here. How to construct the logic NOT operation. So this is what we'll be using. Now, here let me introduce to the saturation also that one. So here when earlier what will happen? When I see 0, then what you should call this as a cutoff. When current IC is flowing, then you should call that as a saturation. V naught or VC this is. No. So what is this? This particular state is called like a cutoff. Now the transistor is in cutoff state. Here transistor is in saturation. Collector current will be maximum. So therefore what is this? You have to call this as transistor is in saturation region. Here transistor is in cutoff. Okay. This is like I just wanted to cover almost all basic things in one numerical. Just I picked up like this and all. Now, sir, I will adjust the value. But by adjusting RB/RC, you can make it transfer to be in saturation cutoff. You do one thing. RB, you take it some 50 kilo ohm, or say like some other values. No, you can bring it to an active region also. So how to make the transistor to be in active region saturation cutoff? By adjusting RC RB value, not this input voltage. By varying value of RB and RC, we can make the transistor to be in saturation or cutoff. Okay, there is no limit. Like this, I can keep on dump numericals. Okay, let me